and welcome to this series of electrical A6 power systems and machines. And this question is from the fall of 2022, so it's after the pandemic. And this question is about transmission lines. This is my first time basically dealing with a question about transmission line in A6. I used to see this type of questions in basically in B7, but after the COVID, I start to see there is sometimes they use topics interchangeably between A6 and B7. This is, without exaggeration, one of the easiest question I have ever encountered in all PEO exams that I solved so far. So it says here the per phase loss of a 40-kilometer long lines with an overhead lines not to exceed 60 kilowatts. So that's like a criteria. And when basically it's delivering 100 amps. So when we have 100 amps, the losses should not exceed 60 kilowatt. You are given the resistivity of the conductor material. Then we want to find what is the conductor diameter, and then they give you the DC resistance of the line is basically 6 ohm. So let's see this question. Now here we have a criteria. We said that the losses, the P loss, should not exceed 60. So that would say it's equal to 60 kilowatt. It's 60 kilowatt. But now when you have it, this is a 40 kilometer overhead line length. So this is a short model. The short model is basically a resistance in series with an inductance. This is how it is modeled. So this is a power loss is equal to I squared times R. This current that goes here, this is the sending and the receiving. They are the same current because there is no any shunt element. So this is equal to I squared R. Now assume that we don't have the R. They did not give us the R. So your R will be equal to the 60,000 divided by I squared, which is 100 squared, which is equal to 6 ohm, which is this value. So even if it doesn't give you the value of the resistance, you don't need it actually. You can easily calculate that. Now R, and this is the formula, this is maybe the only thing that you missed, because if you miss the formula of R, then you'll miss the whole question, is equal to rho L divided by A. So if I have a conductor with a cross-sectional area A and length L, and resistivity equal to rho, then this is basically your resistance. So we know the resistance is basically equal to 6 ohms. Equal to rho, we have it 1.72 times 10 to the minus of 8 ohms dot meter. Now, very important here to watch also the units so that you will not get the wrong number. So this is ohm dot meter times the length. What is the length? This is 40 kilometer or 40 times 10 to the power 3 meter. I will convert that to meter divided by basically the cross-section area A. So your A will equal to 1.72 times 40 times 10 to minus 8 times 10 to the power 3, 10 to minus 5 ohm dot meter square divided by the 6, and this is in ohms. So the ohm will cancel, and this will give me a cross-section area equal to 1.333 times 10 to the minus 5 meter square. We can convert that to centimeter square by dividing by 10 to minus 4 or multiply 10 to the power 4. So this is equal to 1.333 times 10 to the minus 5 meter square times centimeter square by meter square. And then we basically centimeter square. So this is 10 to the power 4. So this will give me basically 1.133 centimeter square. So that is your cross-section area. Now this area, the 1.133 centimeter square is equal to pi r square. So your r is equal to 1.133 divided by pi under the square root, and this will give me around 0.6 centimeter. So they asking for the diameter. So your diameter is equal to 2r or equal to approximately 1.2 centimeter. So as you can see here, it's a very simple, very straightforward question.